Hi everyone, in this video we're going to take a look at the process of rendering an animated sequence from Arnold with an alpha channel so that it can be composited in After Effects or other compositing software packages. We're just going to cover the basics of this so that you can get this process done quickly or as quick as possible. So let's take a look at what we need to do. So first thing is I've got my scene. I've got this animated here. Just to speed up the animation process for myself, I've used a bullet simulation, which basically uses collision objects to get the text to kind of explode. So rather than hand animating this, I've just kind of taken a quick shortcut to get a bit of animation for you guys as a demonstration. This video is not about animation or physics or anything. This is about rendering, but I needed something to render. So I've got my sequence. Usually speaking, what you'd want to do is make sure you've got your lighting set up. The file that was given to you guys had a light in there. If I go to the show menu and switch on lights, you can see that we've got this Arnold area light just here. It's set up to give you a reasonable amount of illumination so that you can see the text without having to make any changes to the lighting itself. But obviously some of you might want to experiment a bit more with some additional lighting, so you can always add more lights and play around with it. But ideally we do need to have a light in there for this to render properly. Okay, so I'm just going to hide that light again so that it's out of the way. If you're playing around with lighting, what you'll want to do is do test renders. So when you add a light into the scene and you're adjusting its settings, what you'll want to do is actually test render what we're looking at. So what you can do is go to the Arnold menu and hit render. You can add additional lights from here, area lights. So if we go Arnold render, what we'll get is this panel pop up and it will start rendering the image. You can see down here in the bottom corner it's saying rendering. It's telling us how big the picture is, how far we're zoomed in. So in this case I'm at roughly 50% of actual size. So if I went to 100% or 1:1, this picture would actually be twice the size that it is, and it would fill roughly the entire screen. Our samples, these are basically samples which are almost like you could kind of relate them to a quality setting for different elements of the render. Things like the amount of reflection, or like reflective and specular quality, translucent quality, general anti-aliasing quality, which is sort of the sharpness of the edges of the objects, and so on and so forth. So you can see here it's taken 19 seconds to render this image, and if we look at this at 1:1, we can actually see how sharp the edges are, whether or not they're stepped or aliased, where we can see the individual pixels, or if they're smooth enough for us to be happy with the result. This is reasonable. This is really just the default settings, but for this example I'm happy to leave them at that because it's going to give me approximately a 19-second per frame rendering speed. This can vary though based on things like the object's distance to camera and the amount of lights in the scene, and also sometimes how big the images we're rendering, or how many lights have got active shadows, the quality of those lights, and so on and so forth. There's a lot of different factors that can affect your rendering time. We're just going to look at a couple of the basics. So if I maximize this for a second, this is basically what it's going to look like. Okay, you can see the lighting's a little bit blown out in the middle, but as I said, this isn't a lighting exercise. This is a rendering, basically just like a rendering export exercise, rather than it being a lighting and texturing exercise. Okay, so I know it's going to render. I know that I'm going to get some kind of image. So what I want to do is first take a look at the quality settings and then the export settings for a basic image sequence render. So what we're going to do is we're going to pop up to the render globals, which is sort of our main render settings, okay, just up here. Let's pop that open and bring this down off my second monitor. So these are our render settings. Depending on the software, usually it'll be called render globals or render settings. Okay, so the first tab, the common tab here, is always active, regardless of which render you're using. So the rendering systems that you'll use, generally speaking, will always have this common tab. If you have third-party renderers like RenderMan or Redshift, things like that, you may find those in this list, and it will give you a different set of tabs along here based on their settings and the way that they function. At the moment, I'm going to use Arnold Render, which is sort of the new default sort of high-quality renderer within Maya. Another common renderer that's often used is Maya software, but it has a few limitations compared to most other higher level renderers, and to get the same amount of quality out of the renderer, you've got to do a little bit more adjustment with the settings. There's several things that it can do by default, there's several things it can't do by default which other renderers do, but you can achieve those results by changing a lot of the settings in the Maya software renderer. So what we're going to do is use Arnold. Okay. So if you want to do a render, as I said, go to Arnold and you can hit render, and that's going to give you your render view. As you change settings inside the Arnold renderer tab just here, if you've got the render view open, it will most likely update with the new render settings, and you'll see potentially see some difference in the quality. I might actually activate that, so we might see a little bit of an example of that as we work. So I'm just going to shrink this down. I don't need this to be I don't really need the window to be that big, but it does help if you're viewing it at 1:1. If you zoom in and out on this window like this, it doesn't necessarily always display the image at full quality. You might find that it pixelates a little bit if you zoom too far in or too far out. So 1:1 is probably the best option for the zoom for this. Okay, so before I do my export settings, I'm going to pop across to my Arnold render settings. Okay, I'm just going to give you a quick overview of these, but I'm not going to really play around with them very much, because that's sort of something that can take a lot of time, and it's different for every scene. And obviously each of you will probably have your own idea of what quality you're happy with. Okay, so the way that Arnold functions is based primarily off these sample settings. So each of these sample settings covers a different part of the visual quality or the visual attributes of a render, regardless of what you're actually rendering. Now, some of these will be sort of existing within the scene, and some of them won't. So we'll kind of just have a quick look at these and take sort of give you a bit of an idea of what they do. So your camera anti-aliasing is sort of like your overall quality. A lot of that is going to be things like it's the anti-aliasing on the object itself. So aliasing is where you get, for instance, we can see some just there, where you can see visible stepping in the pixels, like that. So along the top here, it's actually smooth. It's anti-aliased here, where it's blending from the black into the object. So we get this slight soft edge. Aliasing is where it's actually stepped and you can see it. So depending on the camera setting, if you increase this value, it should reduce the amount of the stepping that you see. But that normally happens, as I said, it'll happen in this image if you're not viewing it at 100%. And it currently, because I've zoomed in, it's actually showing up at 200%. So if I go back to 1:1, I can see a little bit of the aliasing just there. So technically speaking, if I increase the camera AA value a little bit, it should reduce that a little bit as well. By doing that, you can see currently we've got a 19-second render. If I increase this to 4, it might reduce that visibly a little bit, but the rendering time I would expect to take more than 19 seconds now. So the whole process of refining these settings is about balancing the quality of the image that you're happy to accept with the amount of time it takes to render. So there is no specific number that you have to achieve. It's all down to how much time do you have to produce the work and what quality are you willing to accept. And it's a balance. So for instance, you might decide, see, for example here, it's now taken 33 seconds instead of 19. So that's an extra 14 seconds per frame. Now I can actually still see a little bit of the aliasing there, which means I've not gained very much quality, but I have almost doubled my render time. So the trade-off there to me is probably not worth it. I'm not seeing much improvement, but it's going to take me almost twice as long to render. So I can drop that back down to 3. Like that. Okay. Diffuse. This is going to be largely affecting things like shadows. Specular is going to adjust the quality of your reflection, reflections in your surfaces, and also the shininess or specularity, which technically speaking is a reflection of light sources within your 3D scene. So it's going to either increase the quality of objects being reflected in other objects, or the lights in the scene being reflected off the objects and causing those very white, bright, specular highlights. Transmission is based around objects which, for example, objects that self-illuminate like a light bulb. Triple S is subsurface scattering. That's basically a translucency effect which is really common on skin. So if you look at characters like Gollum, if you look at all of the Pixar characters since the first Incredibles film, anything where they've got that nice, soft, slightly waxy looking skin, that's being generated by a subsurface scattering effect. Basically, light in the scene penetrates through the surface of the object and it scatters through the object's surface, and then as it passes back out, it gives you that semi-translucent effect. It's basically a visual kind of, almost like a texturing and lighting trick to make surfaces look more like either wax or skin. And the volume indirect is going to be based on volumetric properties, potentially lighting effects that have a volumetric effect through it or a texture through it. So think of things like light passing through smoke, that kind of effect. Okay, we don't have any of that, so we don't really need to worry about that. So depending on what you've got in your scene, you can dial these up and down. So technically speaking, if we don't have any transmission, we could actually reduce the transmission value down to 0 because we don't need to calculate that. We don't have any subsurface scattering, so technically I could reduce that as well. Now you can see there the color of the surface changed a little bit. Now what that means is the material that I've got on this surface may have had a little bit of subsurface scattering active, which is causing this sort of orange effect. Now I know that the material that I placed onto the surface doesn't have that color on it. So I think possibly the actual picture that I put on, which is giving me this sort of slightly mottled kind of worn metal, didn't have that effect on it. Okay, it should be grey. I think the material it's plugged into, though, which I believe I might have used like a brass or a copper material originally as the base, may have had some subsurface scattering applied, which is why it was going orange. But if I don't need that effect, I can just turn it off, and that's what I'm going to do. Specularity, there is a little bit on there. It's a slightly shiny material, so I can leave that where it is. Volume indirect, I don't need that, so I could switch that off. So technically speaking, you can reduce the things you know you're not using, and that can allow you to actually increase other things you know you are using. So for instance, I might increase the diffuse a little bit, maybe up to 3. I might increase the specularity a little bit. So if there's a little bit of shininess or reflection in there, that should hopefully increase that. And technically speaking, I could probably pop the camera AA up a little bit as well. I'm going to take a look at my rendering time based on these settings, where I've got 333000. Remembering before, when I increased the camera AA just to 4 by itself, it was 33 seconds, up from 19. So if I'm still getting somewhere between 33 and 19, then I'll leave the settings as they are. I certainly don't want to go over 33 for this. So let's just see what happens. While that's still going, the other thing that we need to be aware of is the ray depth. Now, these numbers here, you'll see that some of these actually coincide or are the same as some of the settings here. These are the number of calculations that are used to generate that particular quality on your render. Okay, so these are the quality settings. These are the maximum amount of calculations that can be used, or the maximum amount of penetration, I should say, of the calculations through polygons. So when we're talking about something like transparency depth, just here, if I have, let's say I've got 11 polygons stacked against one another, and they're all transparent. If I've got a transparency depth of 10, a visual calculation from the camera can see through the first 10 polygons. But when it gets to the 11th, because I only have a depth value of 10, the last polygon, the 11th polygon, would end up rendering solid instead of being transparent. So the transparency depth is basically how many polygons we can actually see through, transparent polygons we can see through, before it starts to render them sort of as an opaque render. Rendering an opaque polygon is quicker than rendering a transparent polygon. And so this can allow us to kind of say, okay, with transparencies, I will allow you to render this many transparencies before it stops rendering them. More often than not, you'll probably not have more than about 4 or 5 transparencies. You know, if you've got like a, let's say a glass bottle, and you're rendering through. So normally a value of 10 is pretty common. Sometimes you might need to increase it, and oftentimes you can actually drop it a much lower down. Okay, so while we've been chatting about this, and this has been rendering away, this is one of the things to look out for with this. This window kept saying rendering here. It actually only took 10 seconds to render the image, but this interface glitches sometimes, and it doesn't stop saying rendering. So what I did was actually move this window a little bit and resized it slightly, and then this actually just stopped and switched over from rendering to 10. So this is only taking 10 seconds, but it doesn't always update this to tell us that that's the case. So I'm happy with that. 10 seconds for a render, that's good. I'm going to press this little stop button here just to stop this from updating. So I'm quite happy with that set of quality settings. Okay, so that's giving you a little bit of an idea of how this works. So you basically adjust these numbers based on, you know, the overall edge quality that you want, the quality generally of the shadows that you're rendering, and the reflections and shininess. Keep in mind things like the shadows, where we're looking at diffuse. The shadow quality can also be adjusted in the lights. So if you select a light and go into the attribute editor for it over here, you will actually be able to adjust the samples on the lights themselves. Just to show you that very briefly where it is, I'm not going to play with it. If I select the light here, we pop over to here, we've got samples just here. This is the quality value of the shadows that will come off this light that's in the scene. So if you increase the samples a little bit, you should start to see nicer edges on the shadows where they're visible. Okay, so just bear that in mind. Just increasing this value here will not necessarily increase your shadow quality. You would need to increase the samples first down here to increase the shadow quality, and then adjust this to increase the rendering quality of those shadows. Okay, so that's sort of how the lights work. I'll just hide those lights again, get them out of the way. Okay, now what I'm going to do, just as a bit of a quick test, I'm going to come down my timeline to a point where my text breaks apart, like this. And what I'm going to do is just render that shot, just to see if it's actually rendering properly. And it looks like it is. I can see that it's obviously rendering the fragments. There's going to be some shadows in there. I can see that. As I said, it's quite overblown because of that light. So I'm not overly concerned with that, really. As I said, this is more of an animation exercise than anything else, and this video is the rendering of that animation. So that's going okay. I can see that this is still rendering, and as I said before, usually if things get closer to the camera, it takes longer for them to render. And I can still see pixels here generating. So potentially the render time on this is going to be quite varied depending on the layer that we're on. So I'm not too worried about that. Let's just stop that render there. Okay, so once we're sort of happy with our render settings like this, what we're going to do is pop over to the Common tab, and we're going to set up our export settings. Whoops, didn't want to do that. There we go. You've got to be careful when you're dragging these panels because they'll actually snap into the interface. Okay. Now, before we get started, the very first thing you need to do is make sure you have set your project folder. Just here, you can see where it's going to export these settings. It's going to put them into my project folder, which I've got on my desktop, and it's going to place them into the images folder. I'm going to pop over to my folder, just here, and I'm going to double check that my folder is my images folder is actually kind of emptied out of other files that might be in there. So let me just grab another folder window here for a second. Okay. Yep, that one will work. All right, so this is my project folder on the desktop, and if I pop this down into here, let's go into the images folder. Okay, you can see that the images folder is empty. Okay, so basically here, that's what we want. All right, now if you haven't set your project folder properly, go to File, Set Project, and then basically select your project from your drop-down list. Just go into the folder, just go into the actual project folder and hit Set. Okay, and that'll set the project folder. So just double check that this is going where you expect it to. If you don't and you're at school, you might end up rendering your files into someone else's project folder. Okay, so you've just got to make sure that you're not doing that. Okay, below is the file name that it's going to export, and it also tells you the extension, which at the moment is .exr. Okay, it'll also tell you the render size. So what we want to do is go down and work these settings out. First thing we're going to do is set a file name for our renders. If you don't, it'll use the file name of your file, and I've got quite a long file name. So what I'm going to do is rename this. So I'm just going to call this, you know, sort of T. So T for Transformers, because that's what the text is. And then I'm just going to call this text logo, and then I'm going to put an underscore in like that. Now notice that when I type this in, it doesn't change anything here because I didn't press enter. So what I need to do is type it in and hit enter, and it then updates here. So as long as you're hitting enter when you change the settings that you're typing, it should update. Always double check here to make sure what you're seeing is what you expect to see. If you think it should be something different, it might be you haven't changed the setting properly. Okay, so next thing is image format. technically speaking, an EXR is going to work for this. It'll have an alpha channel in it. Just to make it a little bit easier for you guys, because this will be the first time you're doing this, I'm going to change the format to something a little bit more common. I'm going to use a PNG for this example. You could also use a TIFF for this, because it's going to give you an alpha channel. A PNG will, a JPEG will not. So don't use a JPEG, okay? Usually EXR will do. PNG if you want small file sizes. I'm just going to go PNG because they're easier to for you guys to open and recognize. You know, we've got formats and things like that. You know, if you want to go with a 16, you can. It doesn't really matter for this. You can pretty much leave the settings as they are. All right. What we do need to do is change the frame animation extension. You can see here it says name, which is whatever I typed in here. Extension, which is .png in this case. And then it says single frame. What that's going to do is render frame 1 and nothing else. It's an animation, so I need to render out everything. Okay, my whole animation. So what I'm going to do is change this down to, I tend to use this bottom one, name underscore number, frame number, and then dot extension. What this is going to do is it's going to put this name and then an underscore, then the frame number, like frame 10 for instance, and then the extension, which is PNG, just here. Now I've already put an underscore in, so instead of using the bottom one, I'm going to use this one. So if I select it, you can see now it changes up here. So now it's going to call every frame T for Transformers, Transformers text logo, and then an underscore, and then the frame number and PNG. So that's going to work. You can see now it's saying file name frame 1 to file name frame 10. So it's going to render 10 frames with the current settings. The frame padding is how many digits we get in this number. So the frame padding is set to 4, which means I get 4 numbers here. So 0, 0, 0, 1, that's 4 digits. Now I'm only rendering to frame 100, so I only really need 3, a 1, a 0, and a 0. So what I'm going to do is just reduce that down to 3. You have to set this. If you don't, it may, if the number of your frames that you're rendering goes over this number of digits, it will actually not keep your frames in the right order. So when you import it into things like After Effects or Premiere, it'll scramble the order of your frames up and your animation won't play, because all the frames will be in different spots. So you have to make sure you've got your frame padding set to the number of digits in your highest frame. So if it's 100 or 999, it's going to be 3. If it goes to 1,000 or more, up to 9,999, it's going to be 4 digits. Okay, so now we can move down and set our start frame. My start frame should be frame 1. So I'm going to set this to frame 1. Now sometimes it'll change like this if you change your frame rate after you've animated. So what you want to do is just make sure that this is set to 1, hit enter, and you can see here it says like 10.417. Up here it says 10. Just round this up, okay? So I'm going to go to 100 there because I'm rendering to frame 100. By frame is how many frames it renders in, as far as if you set it to frame 1, it will render every frame. If you set this to 2, it will render every second frame. So that's good if you want to do like a quick kind of test render, but you don't want to render every frame. You can render every second frame and then stretch your sequence out in After Effects or Premiere so that it goes for twice as long. So that way it ends up being the same duration as your animation, but it's only rendering half as many frames. That's one usage for it. Okay. Now what we want to do is we want to make sure we've got our renderable camera set. We're actually rendering from the perspective camera in this file. Okay. So we can leave this as it is. We want to set our size, image size, which by default we're doing 1080 HD. Okay, so you just come down the list and go HD 1080. There's a whole range of other ones in there, and they even have print resolutions like A4 paper and so But what we're doing is 1080 or 720 if you want to maybe speed your rendering up a little bit. Obviously, you'll get a lower resolution image. So once you've done all of that, that's it. Basically, we're ready to go. There are no additional settings down here that we need to do for this. We're just doing a basic render. So this is pretty much it. Okay, so we've got our name and our file type and our extension. Down here, we've told it how many frames to render. Here, we've told it which camera to render from. And here, we've told it how big we want it to render, our final output size. Okay, so we're going to close this, and we're going to save the file. So we go File, Save Scene. What that's going to do is save those settings with the file. So if you move this file to another computer and you open it up, those render settings will already be set. Okay, so the handy thing with that is if you're manually moving this file to multiple computers so that you can render off, different frames on different computers, you can, or maybe you render half of your render at school, and then you stop it, and then you take it home, you can render the other half at home. The way that you would do that is, what you do is let's say you render up to frame 50, so you've set it to 1/100, and then you get to frame 50 and you've got to stop it by hitting escape or, cancelling the render. When you get home, what you can do is change this number to 51, and it will start rendering at frame 51 and render the rest of your sequence. And then you just take the files that you did at school and the files that you did at home. They should all be in the same folder, and then basically you've got your whole sequence done. Okay, and that's why we render as image files and instead of a video straight away. Okay, so we've saved the file. Now what we want to do is render. So we're going to go to this drop-down menu here, our menu set. We're going to go to rendering, just here. And we're going to come across to the render menu. And we have render sequence. Now there's two rendering processes here. We've got render sequence and we've got batch render. If you're using the full version of the Arnold, this Arnold renderer, okay, so if you've paid the license fee to get the full version of Arnold, then you can use batch render. If you're just using the normal installed version of Arnold that comes with Maya, which is what we're using, you need to use render sequence. The difference is render sequence will render the animation as you would expect. Okay, at the size you've set it at with no watermarks and everything like that. But while it's rendering, you cannot use the software. It locks Maya down. You can't do anything in the software while it's rendering. So it's basically rendering in the foreground. That's what that is called. If you've got a licensed version of Arnold that you've purchased and installed, you can use batch render, and it will allow you to continue to work with Maya while it's rendering. It will render in the background. Okay. Now, if you do a batch render without the license, it will render, but it puts a watermark over the top of it. So it basically will print text over the top of your render. We don't want that to happen, so we're going to use render sequence just here. We'll take a quick look at the options just so you can see what that is. Okay, it's important to check these settings and make sure that your current camera is set to the camera that you are wanting it to render from. This does not change even if you've got it set in here. So when you change this, it doesn't change here. So you've got to make sure that if you've got a camera that you want to render from in here, like let's say we add a camera and it's called camera 1, you need to make sure that this is set as well. Changing it here doesn't change it here. They've both got to be set to what you want. Okay. Basically, there's pretty much really nothing you need to do here, except for double checking that camera if you've got more than one possible camera in the scene. So once you're happy with that, you can just press render sequence and close. And what you'll find is the little render view window will probably pop up. It's popped up on mine on the other screen, and it's starting to render now. And I can see my actual picture rendering. Because it's rendering, I can't move it. because it locks the software down. But I can actually see the Transformers logo rendering in a little window. If you've only got one monitor, it'll pop up. It should pop up here somewhere. Okay. So basically what you'll find is those pictures will start to render and appear one by one in your folder. So you can see here, they're actually popping up like this. And if I open one of those up, fingers crossed I can display it. There it is. That's what it looks like. So what we can do is, once these have all rendered, we can load this into After Effects and put a backdrop in, and, you know, do some manipulation and create a little sequence with it. So that's it. That's the process. That's how to render. So this video, I know it's, you know, about 35 minutes, but we've kind of covered a lot of things in here. And this is basically everything you really need to know to make the software render your animation out at a basic level. There's obviously a lot of different additional rendering processes and lighting processes and things that you can do in the software. But just to get your first animation sort of out, this is pretty much your process. Obviously you can do additional research into more advanced rendering systems, processes and things like that, more advanced lighting, and even texturing and so on, which is generally done as part of, oftentimes part of the modeling process. So yeah, there's your rendering system. So give that a go, and I will see you again soon.